In Chapter 4, we will introduce the concept of probability and uncertainty, first with a focus on counting rules. Rarely in business are we 100% certain. We must base decisions on uncertainty. One additional, more detailed example, suppose you own a trucking firm and must quote future business, and the single largest part of your cost is the price of diesel fuel. You know that what the price of diesel fuel was in the past, but you're uncertain of the future value. But in any case, you need to make decisions to quote a price. There are a few simple rules in assigning probabilities. Unlikely events have probability near 0. Highly likely events will have probability near 1. This is described simply in this diagram. When we discuss statistical experiments, they're different than scientific experiments. In statistical experiments, probability determines the outcome. Even though you repeat the experiment in exactly the same way multiple times, an entirely different outcome can occur. This is randomness. Throughout this chapter, we'll use the terms sample space and sample point. The sample space is that set of all possible outcomes in an experiment or a situation. Here are some examples of sample space: tossing a coin, inspecting a part, etc. Through this chapter, the experiment of Bradley investments will be quoted and used. There are 4 possible outcomes for the oil stock and 2 possible outcomes for the mining stock. It can be useful to represent a statistical experiment and its outcomes with a tree diagram. This example can be viewed as a 2-step experiment. It involves 2 stocks. Each one we'll call a step. There are 4 possible outcomes for the oil stock and 2 for the mining stock. We can see that the total number of possible outcomes is 4 times 2, which is 8. As you can see, this tree diagram leads to a total of 8 combined stock outcomes. There are 2 counting rules that become the basis for some statistical calculations. The first is the rule for combinations. We can calculate the number of possible outcomes when we take small n objects out of a total of capital N objects. The formula indicated here uses a mathematical function called the factorial, designated by the exclamation point. An example of combinations could be using the lottery. If you were to pick 5 different numbers in the Powerball out of a total of 59 different possible 2-digit numbers, this formula could be used to calculate the total number of possible combinations of those 5 digits. An additional counting rule is that for permutations. Similar to combinations, the formula is modified to reflect the fact that the order of selection is important. In the Powerball lottery, it doesn't matter what order we choose the 5 numbers, as long as they match the winner. If that order were important, this formula would yield a much higher number of possible outcomes. The text includes some good examples of calculating combinations and permutations.